Okay, so in this video, I'd like to talk about what to think about when we're using Newton's second law and some important considerations to make. So we've said before that force is related to mass and acceleration. And if you have a force, generally you'll have an acceleration. Or in other words, your velocity is going to change. However, the change in your velocity will depend on your mass. If you have a force on a big object and then another force on a small object, the small object is likely to have a bigger change in velocity than the very massive object. So what are some important things that we must consider first of all when we're using Newton's second law? Well, one of the first things is that look at this example here. We've got a force right there acting on an object. Say it's a 5 Newton force, and we've got a 2 kilogram object right there. So if we wanted to calculate the acceleration of this object, it would be really quite easy. We say force is equal to the mass times the acceleration. 5 is equal to, what's the mass? The mass is 2 and the acceleration is a. So when we move the to the other side, we'll have a being equal to 2.5. So what do I need to introduce first of all? I need to introduce a bunch of new units. First of all, force. The unit for force is the Newton. It's named after Sir Isaac Newton. The unit for force is the Newton, and it's an important unit to remember and should be able to convert to it. And then the unit for acceleration we've talked about already. It's meters per second per second. That says that what is the change in your speed, change in speed over time. So if your acceleration is 2.5 meters per second, that means every second, maybe you're driving a car, you start out at 0 meters per second. 1 second later, you add on 2.5. Another second later, you add on another 2.5, so you're at 5. Another second later, you add on another 2.5, so you're at 7.5. So you're adding on 2.5 meters per second of speed each second. So what's another important thing that we must consider here? Something else that's really important to consider here is the force. This is a 5 Newton force and we've got an acceleration of 2.5. We must understand that basically this acceleration will be in the direction of this total force here. So if you've got a 5 Newton force here, this object is going to speed up in that direction. We can actually sometimes represent it with an acceleration with a double-headed arrow like that, and then we say 2.5 meters per second to the power negative 2. So the 2 kilogram object is going to accelerate in the same direction as that force in that with that magnitude of acceleration. But the question is, what if I had more than two forces? What do I do then if I had a 5 Newton force and say a 2 Newton force? Let's start with one acting in the same direction, a 2 Newton force acting in the same direction. So this is where it's important to understand what the F in F equals ma stands for. The F does not just stand for one of the forces. The F stands for the sum of all the forces acting on the object. So not just the 5, but the is going to be 5 plus 2 will be the force. 5 plus 2 is equal to the mass. Let's give it a mass of 1 kilogram. 1 times the acceleration. So 7 is equal to 1a. In other words, 7 is equal to a. Now, how do you think about the direction? Well, because both these forces are acting in the forwards direction, the acceleration is also going to be in the forwards direction. Think of it as two people pushing on an object in the same direction. It's going to move in the same direction in which they are pushing. Question is, what if someone is pushing forwards and someone is pushing in an opposite direction? So say someone is pushing here with a 5 Newton force, but someone is opposing their movement with a 3 Newton force. What's going to happen here? Well, this we have to think a little bit more differently. If you're pushing an object and there's no one pushing against it, usually you'll find that it will be easier to push it. You'll push it more easily and cover a distance. But if you have someone that's opposing you, you're going to find it a lot harder to push the object. So this time, as we said, the F stands for all the forces acting on the object. So it's a 2 kilogram mass. So if there's a 5 Newton force and a 3 Newton force, this F must say 5, it must include the 5 and it must also include the 3. But this time, instead of adding them, we're going to subtract them. Why? basically, because they're in opposition to each other. So is equal to 2 times A. So 2 is equal to 2 times A. So we see here that the total force is 2, right? And then the A will be equal to 1. So it's going to speed up with a speed of 1 meter per second in a certain direction. But which direction is this? Well, we have to look at these two forces. We've got a 5 Newton force here and a 3 Newton force here. Which one do you think is going to push the other away? Well, this bigger force is most likely going to be a lot stronger than the 3 Newton force. So the object is actually going to speed up in that direction. They're like that with an acceleration of 1. That's part of the introduction to what the force in F equals ma stands for. And in the next video, we'll look at more examples of that.